Hey folks, we are Carter
and Khrushchev,
studying computer engineering at BU, and we're here to talk about our FPGA project, which was almost as ambitious as caffeine intake during finals week.
For this project, we set out to tackle three main features. Those features being the multiplication, the speaker, and the VGA features. We chose to implement these not because we could, but because we wanted to push beyond the limits of a regular FPGA project. No temperature sensors here, just cool ideas.
First up, our multiplication feature. This piece of code was the method of our project. Quick, accurate, and always brought us the result. We multiplied numbers like there's no tomorrow, and trust me, in a world of ones and zeros, that's a party.
Here's the multiplication code. All of it's in our module called multiplier. At the top, we've got some inputs and outputs that are each 4 bits. Because we're multiplying two numbers that are 4 bits, and normally we'd expect us to store those in a 8-bit value. But here, what we did is we found the multiplication values 16 modulo. So what remains from the answer to that multiplication when we divide it by 16? That's the value we're storing for the final answer. Below our inputs and outputs, we've got the internal wiring that we need to connect the partial products that we have right below. Using the partial products, we find what we're supposed to do for every single bit, and then at the bottom, we add the partial products together using our own built-in carry select adder. Another thing that I want to address is you can notice that the last adder actually shows that the cout3 is simply not being used, but that's because we actually don't need cout3 because we're taking the 16 modulo of the answer, so that's not going to be relevant. That's why we didn't need to implement that further. Now let's move on to the VGA code. The idea was to paint the town some type of color that's a combination of red, blue, green, and that color would depend on the opcode that we decided in the ALU module. And we did define the colors like Picasso, but unfortunately, we couldn't quite get it to display on the FPGA properly. I guess you could say we were a little bit off color.
As you can see here, we use a case statement. In any programming language, a case statement allows you to control the flow of an expression via a multi-way branch. It takes one argument, and in our case, we're using the opcode as our argument. Every time the opcode changes, we should be able to get a color. For instance, if the opcode is 000, we should be able to get black, 800 should be red, and so on. For the speaker module, well, it was supposed to beep as many times as the opcode value. It was like that song you can't get out of your head, except it didn't quite know the lyrics.
Our aim was to make a beep sound. A lot of things don't work here as they're supposed to. The general idea for the speaker code, as Carter mentioned, was to make a speaker beep the same number as the opcode from the ALU module. We were about to implement that, but we later realized that the waveforms that we were trying to form, the square waves, were not what we were supposed to be doing to create those beep sounds on an actual speaker. The problem here was that we didn't actually understand what we were supposed to do. But what we were able to implement here was actual square waves that go up and down. Those are not the same number as the beep count because we actually could not get that to work either, but our code basically implements that feature in a limited manner. And here is our ALU code. This is a snippet from the ALU module that just shows the instantiation of the modules that I showed previously. And Carter showed the VGA, and I showed the speaker decoder, and you can see the instantiation of both of those modules here in our ALU.
Our code snippets were like the ingredient to a gourmet recipe, each with a function, each supposed to create a feast for the senses. I mean, we had success. The multiplication was like a smooth dance, step by step, number by number.
But the VGA and speaker, more like stepping on your dance partner's feet. A little awkward and a little bit painful, but a lot of learning.
So what can you take from our Techno Tango? Well, even if you don't hit the mark, there's value in effort. In real life, the best projects like the light bulb or the smartphone all came from trials and errors.
Here is our simulation file that you saw at the beginning of the video as well. You can see from here the square waves we were talking about for the speaker decoder output. And you can see that our multiplication works for the inputs 2, 3, which gives 6, for example. That's basically it, though.
I'm the narrator reminding you to keep coding, keep experimenting, and for the love of engineering, keep your sense of humor. Because in the binary world, one laugh is worth 1,000 bits. Thanks for watching. Don't forget to hit the like, subscribe, and ring that bell faster than our speaker module goes beep.